Today, NASA's James Webb Space Telescope revealed Stephen's quintet in a new light. This enormous mosaic is Webb's largest image today, covering about 1/5 of the Moon's diameter. It contains over 150 million pixels and is constructed from almost 1,000 separate image files. The information from Webb provides new insights into how galactic interactions may have driven galaxy evolution in the early universe. So in this video, we're gonna tell you about James Webb Space Telescope reveals new surprises on galaxy organic molecules near black holes. The video is gonna be amazing, so make sure you stick till the end.
NASA releasing a slew of new full-color infrared images.
We are still wondering in awe after looking at the breathtaking image released by NASA's
James Webb Telescope, the largest and most powerful ever launched into space.
The James Webb Space Telescope is the world's premier space science observatory. Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA with its partners ESA, European Space Agency, and CSA, Canadian Space Agency. NASA headquarters oversees the mission for the agency's Science Mission Directorate. NASA's Goddard Space Flight Center in the Green Belt, Maryland, manages Webb for the agency and oversees work on the mission performed by the Space Telescope Science Institute, Northrop Grumman, and other mission partners. In addition to the Goddard, several NASA centers contributed to the project, including the agency's Johnson Space Center in Houston, Jet Propulsion Laboratory, the JPL, in Southern California, Marshall Space Flight Center in Huntsville, Alabama, Ames Research Center in California, Silicon Valley, and others. With its powerful infrared vision and extremely high spatial resolution, Webb shows never-before-seen details in this galaxy group. Sparkling clusters of the millions of young stars and starburst regions of the fresh star birth grace the image. Sweeping tails of gas, dust, and stars are being pulled from the several of the galaxies due to the gravitational interactions. Most dramatically, Webb captures huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. The 5 galaxies of the Stephen's Quintet are also known as the Hickson Compact Group 92. Although called a quintet, only 4 of the galaxies are truly close together and caught up in a cosmic dance. The 5th and leftmost galaxy, called NGC 7320, is well in the foreground compared with the other 4. NGC 7320 resides 40 million light-years from the Earth, while the other 4 galaxies, NGC 7317, NGC 7318A, NGC 7318b, and NGC 7319, are about 290 million light-years away. This is still fairly close to the cosmic terms compared with the more distant galaxies billions of light-years away. Studying such relatively nearby galaxies like these helps scientists better understand the structures seen in a much more distant universe. Research led by Oxford University is the first of its kind to study tiny dust molecules in the nuclear region of the active galaxies using early observations from the James Webb Space Telescope. The study is the first UK-led paper to use the spectroscopic data from the JWST's mid-infrared instrument, the MIRI, and addresses one of the biggest challenges of the modern astrophysics: understanding how galaxies form and evolve. Tiny dust molecules known as polycyclic aromatic hydrocarbons are among the most widespread organic molecules in the universe and important astronomical tools. For instance, they are considered to be fundamental building blocks of the prebiotic compounds, which may have played a key role in the origin of life. PAH molecules produce extremely bright emission bands in the infrared region when they are illuminated by stars, enabling astronomers to not only trace star formation activity but also to use them as sensitive barometers of the local physical conditions. This new analysis, led by the Dr. Ismael Garcia Bernat from the Oxford University's Department of Physics, used JWST's cutting-edge instruments to characterize, for the first time, the PAH properties in the nuclear region of the three luminous active galaxies. The study was based on spectroscopic data from the JWST's MIRI, which specifically measures light in the 5 to 28 micron wavelength range. The researchers then compared the observations with theoretical predictions for these molecules. Surprisingly, the results overturned those of the previous studies that had predicted that PAH molecules would be destroyed in the vicinity of the black hole at the center of an active galaxy. Instead, the analysis revealed that PAH molecules can survive in this region, even where very energetic photons could potentially rip them apart. A potential reason could be that the molecules are protected by large amounts of the molecular gas in the nuclear region. However, even when where PAH molecules survived, the results showed that the supermassive black holes at the heart of the galaxies had a significant impact on their properties. In particular, the proportion of the larger and neutral molecules became greater, indicating that more fragile small and charged PAH molecules may have been destroyed. This brings severe limitations to using these PAH molecules to probe how rapidly an active galaxy makes new stars. This research is of a great interest to the wider astronomy community, particularly those focused on the formation of the planets and stars in the most distant and faint galaxies, said Dr. Garcia Bernat. It's incredible to think that we can observe PAH molecules in the nuclear region of a galaxy, and the next step is to analyze a larger sample of the active galaxies with different properties. This will enable us to better understand how PAH molecules survive and which are their specific properties in the nuclear region. Such knowledge is key to using PAH as an accurate tool for characterizing the amount of the star formation in the galaxies and thus how galaxies evolve over time. The supermassive black hole at the center of the Milky Way may have been crucial to the evolution of the life in the galaxy. These days, the black hole known as the Sagittarius A is relatively calm, but there are hints that millions of years ago it may have been much more active, swallowing down matter and spewing out high-energy radiation, including large amounts of X-rays. Xian Chen at Peking University in Beijing, China, and his colleagues simulated how these X-rays. Our Milky Way galaxy looks quite different from an ordinary spiral galaxy, astronomers say, after conducting what they call the most comprehensive structural analysis ever done of the galaxy. The Milky Way is no ordinary spiral galaxy. According to a massive new survey of the stars at the heart of the galaxy, the Milky Way has a definitive bar feature, some 27,000 light-years long, that distinguishes it from the ordinary spiral galaxies as shown in this artist's rendering. The small yellow arrow points to our Sun. The survey sampled around 30 million stars to build a portrait of the galaxy's inner regions. The survey gives fine details of a long central bar feature that astronomers say distinguishes the Milky Way from more usual spiral galaxies. This is the best evidence ever for this long central bar in our galaxy. Using NASA orbiting Spitzer Space Telescope, astronomers surveyed some 30 million stars in the plane of the galaxy in an effort to build a detailed portrait of the inner regions of the Milky Way. The task is like trying to describe the boundaries of a forest from a vantage point deep within the woods. This is hard to do from within the galaxy. Spitzer's capabilities, however, help the astronomers cut through obscuring clouds of the interstellar dust by gathering infrared light, a type of light that penetrates these clouds. This provided information on tens of millions of stars at the center of the galaxy. The new survey gives the most detailed picture to date of the inner regions of the Milky Way. The possibility that the Milky Way galaxy has a long stellar bar through its center has long been considered by astronomers, and such phenomena are not unheard of in the galactic taxonomy. They are clearly evident in the other galaxies, and it's a structural characteristic that adds definition beyond the swirling arms of the typical spiral galaxies. The new study provides estimates for the size and orientation of the bar that are far different from the previous estimates. It shows a bar consisting of a relatively old and red stars, spanning the center of the galaxy roughly 27,000 light-years in length. This is 7,000 light-years longer than previously believed. The analysis also suggests the bar is oriented at about a 45 degrees angle, relative to a line joining the Sun and the center of the galaxy. Astronomers have debated whether a presumed central feature of the galaxy would be a bar structure or a central ellipse or both. The new research clearly shows a bar-like structure. The Spitzer Space Telescope went to orbit in August 2003. NASA Jet Propulsion Laboratory in the Pasadena, Calif. manages the telescope, Benjamin Astrophysical Journal letters. Let us know your opinion in the comment section below. This was all for today. Hope you liked the video. Do not forget to subscribe to our YouTube channel. Stay safe, and we will be back soon with another video.